Hello, my peeps. This Algebra Nation video will cover workbook page 7 times 6. Yes, that's right. You could have said the commutative property, 6 times 7. We'll do problem number 9.
All right, now this question, I think it looks a lot tougher than it actually is. You're given a sentence, you don't see any actual numbers, but that sentence is actually telling you what the numbers are. It's a sentence, we take it, make it into an equation. Now in this problem, we're not going to see an equal sign. This problem, we're dealing with an inequality. So let's see what the sentence is giving us. Okay, 5 less than twice z is at least 17. So we're setting this up as something is at least something else. Let's start with the sign. Let's start with our inequality. Okay, what could be the possible signs that we have set up? Well, we could have an equal to. If that's the case, we're being told something is equal to something else. We could have a less than. Whatever's on the left is less than what's on the right. We could have a greater than. Whatever's on the left is bigger than what's on the right. We could have a less than or equal to. So something is at most what's on the right. Or we can have a greater than or equal to. Whatever's on the left is at least as big as what's on the right. Well, what do we see here? And at least. We know whatever's on the left is bigger than or equal to what's on the right. We're going to have a greater than or equal to sign. At least means greater than or equal to. Okay. What's on the left? 5 less than twice z is something. So let's see what we have. 5 less than something, okay, is twice z. Twice z stands out to me. If we have twice of something, what are we doing? If I have $5 in my pocket and you have twice as much as I have, what do you have? If I have $5, you have twice as much as I have. You have 5 times 2, you've got $10. Same thing here. Twice z just means 2z. All right, so 2z, but 5 less than that. 5 less than twice z. We can say we have, okay, we have 2z, but 5 less than that. Are we adding 5? Are we subtracting 5? Are we multiplying 5? Are we dividing 5? We have 2z, but we want to take 5 away from that. 5 less than that. 5 less than 2z, we're subtracting 5. We have 2z minus 5. 5 less than 2z. All right, so 2z minus 5, we got our left side of our equation. Is at least what? Is at least 17. Okay, well that's just a number. That's just 17. Guys, we just set up our compound inequality. Now we just need to solve it and graph for it. So I'm going to rewrite it down here and we're going to solve. We have 2z minus 5 is greater than or equal to 17. What we want to do is figure out what z can be. What are those possible values in z? Okay, well, here we have 2z. Whatever term has a z in it, I want to get that term by itself. So we have 5 being subtracted from 2z. So if I have 5 being subtracted, what's the opposite? How am I going to get rid of it? I'm going to add. I'm going to add 5. Whenever I do to one side, I've got to do my other side. Same rules and inequalities as they are with equations. So this minus 5 and this plus 5 cancel out, and we get 2z is greater than or equal to what? What's 17 plus 5? Got it, 22. So 2z is greater than or equal to 22. Are we done? No, we don't want to know what 2z is at least. No, we want to know what z is. We want to know what value z can be. All right, so how do we get z by itself? We're going to divide. We're going to divide both sides by 2. Do we need to flip the direction of our inequality? No, you only flip the direction of your inequality when you're multiplying or dividing by a negative. We're doing neither of those here. We've got positive. So 2 divided by 2 cancels out. We get z is greater than or equal to, what's 22 divided by 2? 22 divided by 2 is 11. We've got our final answer. Z has got to be bigger than 11. 11 or bigger. So z is at least as big as 11. That's the same thing as saying, you know what? 2 times z minus 5 is at least as big as 17. Let's see what that looks like on a number line. All right. So number line, I've got my arrows on both sides. So we've got, let's say, 7, 8, 9, 10, 11, 12, 13, 14. You guys get the point. What number are we focusing in on? 11. Now, can z be 11? Yeah, z can be greater than or equal to 11. So when we have a greater than or equal to, we've got a solid dot. So if z could only be bigger than 11, we would have had an open circle. So if z can be greater than or equal to 11, what numbers could z be? Anything bigger than 11, right? 11 or bigger. So we're going to look at all of our values values greater than or equal to 11. We're going to draw our arrow sign towards our bigger values, towards our big positives out there. All right, guys, that was it. We took a statement, created it as an inequality, and then we solved for it, and we graphed it. If you guys got questions, I want to hear from you on the wall.